But without further ado, if everyone would please join me in welcoming Andrew in talking about the future of cloud software-defined storage with Ceph. Thank you, Andrew.
Cool. Thank you. Thank you for staying. Always good to see that not everybody leaves and switches sessions. So my name's Andrew Hatfield. I work for Red Hat. I run the Cloud Storage and Big Data Group for Australia and New Zealand. But today I'm not going to talk about product, I'm going to talk about community. So you won't get a vendor pitch. So, really quick, what are we going to cover? What is Ceph? So, who here uses Ceph today in their OpenStack environment? I know there's more of you. Don't be shy. Come on. All right. So, who has been thinking about using Ceph but hasn't yet done that? And who doesn't even know what Ceph is? They think it's some weird Greek word. All right. Okay. So, we're going to cover a little bit of what Ceph is. Then, what some of you already know is really cool, and then some stuff that's coming upstream now and in the near future. So, what is Ceph? So, Ceph is a scale-out software-defined storage platform. Underlying it is an object store, and then we have interfaces that provide block, object, and now file as well. So, interestingly, started as file, but with OpenStack usage, block and object have really driven its adoption. But it allows you to decouple your storage from the fridge that you're used to buying and paying half of your soul to. So rather than having this massive appliance that just sits there and whether it's a big fridge or a little fridge, it's only ever a fridge. So if you think of Ceph as a lot of little fridges that you can use to store one really big drink in. So normally we use a fish and a whale analogy, but I wanted to mix that up a little bit. But it allows you to use whatever hardware that you want. So if you like Dell, use Dell. If you like Quanta, use Quanta. Don't want to offend any hardware vendors, but anyone that Linux runs on pretty much, you can use their hardware. So whatever you're currently familiar with in your data center, you can use. Or if you're wanting to drive out cost and use hardware that is good enough that you don't care if it fails because you're in cloud and you're expecting failure to be a normal state, use really cheap hardware and let the software do the work for you. You don't need highly engineered systems. And then on top of that, you get better deals on x86 than you do on a really big fridge that you only buy twice a year. So, there's a couple of different components that make up Ceph. Underlying is this RADOS object store. So every piece of data that gets written to a Ceph cluster gets broken up into little objects that sit on disk. And you can stripe them across as much or as little of that cluster as you want. Generally, the more nodes that you use, the better the performance will be because you get more throughput, more cores doing the work. Then there's an access layer called LibRados or LibRaDOS, depending on your vernacular, that is an interface. And then there are protocols. So there's RGW, which is the RADOS gateway service, which is your object interface for both Swift and S3. And at this point, we don't really expect there to be a winner in the object protocols. Typically we see that commercial products use S3 when doing object, and that open source, bespoke, in-house or DevOps developments typically use Swift. So you're probably going to need both. So having an object store that does both is kind of helpful. Then there's RBD, the RADOS block device. So this is exactly like a kernel block device that you can attach to your Linux machine. And there's two ways you can do that. You can either do it as a kernel module, which I'll talk about later, and you get a block device like you used to when you put something on it, or you can integrate it in with OpenStack directly. And then there's Ceph FS, which is interestingly where the whole project started with SageWheel, the initial developer, and has only just recently in the dual release a couple of weeks ago gone stable enough for the community to recommend you start testing it. But it's got a lot of promise and a lot of excitement behind it. So, really simple picture. If you think of starting at around 10 nodes, scaling up to hundreds or thousands of servers that have lots of disk in them, and that's your cluster. And you can configure that to whatever your application requires. So the way that we're used to buying and designing storage is, I think about, okay, so today I've got this much storage, and I think my growth rate is about this. I go to my boss and I ask for a capital expense of this much. I sell my soul, I get the approval for that, I deploy it, and halfway through the term that I think I'm going to write that off, I've filled it because I now need more. Because we're growing, we're producing more data now than ever before. Now, most of that is food and cat videos, but some of it's actually useful. So the beauty of scale-out software-defined storage, especially with something like Ceph, is that we can think big, but start small and scale as we need. And you can have, depending on how your accounting works, an operational cost model, so that you can just deploy the little bits you need as you need them. And because every node is effectively a storage controller, as you scale out your capacity, your performance increases as well, which is inversely proportional to your fridge, where the more you put in it, the slower it gets, because it can only theoretically push so much through a storage controller. You can see a couple of M's there. So within a Ceph cluster, there's two primary services. One is a mon, or a monitor, which keeps track of the health of the cluster and manages the map and orchestrates the elections of where data is kept in terms of the map. And then there are what we call OSDs, object storage daemons. So that's the actual process that runs, that talks to the physical disk that you're attached. But simply we call it an OSD node, which has disk, and a monitor that looks after the health. And an OSD is the service that runs on a file system that has a device under it. And typically, we recommend you use local disk. Don't attach it to your fridge. You can, just doesn't make sense. So OSDs can start at tens and scale up to tens of thousands. You look at someone like CERN and the Large Hadron Collider. They keep all of their Hadoop metadata on Ceph, but all of their actual data on tape. There's so much. But and they only get, I think it is just out of interest, because I found this interesting the other day, they only get every 30th instance of activity in that light speed, which is kind of interesting. They're so fast. But in terms of the devices, we haven't yet reached a physical limit of where Ceph can go. There's certainly better ways than others to design it, but people like Yahoo are using Ceph to manage all of the Flickr databases. We've got large banks, we've got a lot of research firms, universities. There's obviously a lot of clouds that are just doing it for pure block storage. So as long as you design Ceph correctly, it can be fast. We've had Intel do a number of tests where they've done over 1 million items for running, say, Cassandra as a distributed database. So the idea that distributed storage is slow is not true. And for monitors, because we need an election, we need an odd number of them, which is interesting. In most countries have a two-party system, but a little bit of US primary interest there. So the really cool thing that makes Ceph awesome is this thing called crush. So effectively, crush is a way of describing your physical failure domains in your storage platform. So that goes to, say, your data centers, to your server rooms, to your rack, to your switch, to your server, to your disk. So the way that Ceph works is it's not just smart placement because of crush, but also self-healing. So it will work around failed components. So most of the time when you have a fridge, you've got probably two paths to it. And if one fails, depending on how you've set up your fiber or your iSCSI fabric, you might fail across, and then all of a sudden you've got extra contention and sociability issues. Whereas here, you've always got, because it's just a simple IP network, multiple ways to get to your storage environment. So you suffer fewer performance issues when health is potentially a problem. And because Ceph is designed to be very big, it's not just thinking about, how do I handle failure? It's expecting failure to be a common natural state. That at some point, a network card will be out, a cable will be dropped, someone will break a link somewhere, a disk will fail, a CPU will overheat. At some point, something will be wrong in a large enough environment. And so the beauty of software is that we can work around that easily, and you can get an alert and get your facilities people to fix that for you, whoever that is. So Ceph is organised into pools. So you might think of that as LUNs or volumes, depending on your background. But a pool is a description of what sort of resilience my data needs. So it might be replica 3, it might be erasure coded, it might be no replication, it might be a replicated cache tier in front of an erasure coded tier. So there's lots of different ways that you can describe and deliver storage based on the actual needs of your application. so that you can give your environment exactly what it needs. So there's three main ways that people can consume things like Ceph. You can go to an OEM and they might have an appliance, which is a bit like a fridge, fits some use cases. You can go to a vendor like Red Hat, or there's SUSE, there's Intel, there's SanDisk, there's Dell, there's Cisco, there's Supermicro, there's Quanta, that have got reference architectures based on the type of workload, whether it's capacity or throughput optimized or IOPS, and then t-shirt sizing of big, small, medium, and large. Or you can do everything bespoke. And initially we saw customers doing everything themselves down to, I want this particular processor model because I know that that's better than some other processor generation, and I like this network card better than that one and this driver. Whereas what we're seeing now in second and third and fourth generation Ceph clusters is much more alignment along reference architectures as that community has matured. So people like, obviously Red Hat have been working with a lot of hardware vendors to make sure that the design guides that the community and customers have reflects what you want to do. So integration with OpenStack. So the first thing we'll talk about is object. So in OpenStack, we expect to have Swift, and then applications also often want to have S3. So you can have this RADOS gateway, which is basically just a web server. You can use Apache, you can use Civet Web, you can make it virtual, you can make it physical, you can containerize it, and we know how to load balance web services. We've been doing that for a long time. We do it pretty well. That's basically all that is, and it talks to the Ceph cluster on the application's behalf, and you get that RESTful API that applications expect. So you get user accounting, buckets, etc. Then there's virtual disks. So in an RBD pool, I can have a block device that just goes to my Red Hat Enterprise Linux system, and I put LVM on it and a file system, and hey, I've got a physical block device, and I can do whatever I want to do with it. Or I can go and attach that into QEMU and KVM with OpenStack and do that directly. So we get snapshots, we get copy on write clones, images can be, and typically are striped across the entire cluster. So some really cool stuff here is when you're using something like Ceph, when you are using Ceph as your Cinder plugin for your OpenStack storage, and you're wanting to instantiate your cloud instances, when you're using Ceph for Cinder and Glance, you can do an instant copy on write clone, and your virtual machine boots straight away. There's no need to copy the data to a Nova ephemeral device or to copy it across the network to make it available. It's just done. So everyone wants fast, right? Does anyone want slow? Average response for a room this size. Right, so kind of what we discussed earlier. So in my cluster, I've got all these objects that are striped across it, and I've got my pool where I create my MySQL database block device. I put a file system on it. I present it to my Linux cluster, and bang, I've got some external storage available. We know how to do that, right? We know how to attach disk. Cool. So this is probably what's most relevant, is attaching it with libRBD and talking to a hypervisor. So KVM obviously being the most popular deployment hypervisor in OpenStack. It's fast, it's efficient, it scales higher, wider, longer, faster than anything else. It's really cool. So in terms of what the OpenStack picture looks like, we've got Keystone integration for authentication authorization. We get a token and a ticket, and then I can go and access Swift or S3 for my applications. I talk directly to Cinder or to Glance, and then I can also do Nova storage as well. So in terms of a storage platform for OpenStack, Ceph can do everything. And I'll talk about the one thing that's not mentioned on there in what's new. So, as we saw earlier with the keynote, the OpenStack user surveys, which are great, by the way, so glad that not only does the OpenStack Foundation ask these questions, but that people respond and provide this information for people like the community that develop this stuff to find out where you want to go, is that in terms of storage, Ceph continues to be the #1 storage choice for all types of OpenStack deployments, whether it's test, dev, or production. It typically sits around the 60% mark, 57 to 62, roughly in the last couple of surveys. And the next one down is LVM, and then and that I think is about half. and then it starts to get into single digits as to what customers use after that. Some people want to sweat their existing fridge, make it work a bit harder before they go to mode 2 and start scaling out their storage, like they're scaling out their compute. Ceph is now an OpenStack.org reference architecture for storage. So LVM with iSCSI backing it and NFS have been the two primary storage choices for OpenStack. And with the community using Ceph, the OpenStack community have now made that a reference architecture. So if anyone followed some of the storage stuff at Austin last week, the Cinder driver list, in size, probably 6 font would fill that entire page. There's lots of different Cinder storage plugins that you can use, which is great. But in terms of what the community thinks is a good idea, Ceph is definitely one of those. A lot of people have, and to be fair, accurately, looked at scale-out distributed storage as not that great for random I/O workloads or for low latency I/O, just inherently in its design. So a lot of work has been done addressing some of that. There's been Intel, there's been SanDisk and Red Hat that have been working on that. SanDisk especially in terms of the write performance around SSDs, and Intel around things like DPDK and accelerating things past software in the CPU and making things much more efficient. So if anyone follows MariaDB or MySQL, Percona Live was last week or the week before, and Red Hat had a number of talks there running highly performant MySQL on top of Ceph. So when you start thinking about Trove as database as a service, which is typically MySQL or MariaDB, then that's something that you can consider for small and medium workloads. It's not going to run your Oracle, right? That's where your fridge does do a really good job. CephFS, there's a lot of interest around this. At this point, it's stable enough that the Ceph community thinks that it's ready for people to test. Certainly wouldn't yet go and put your production data or your photos and your life on there, but it's ready for you to test and test where you think the limits are, absolutely provide feedback. And then in terms of file as a service, so the Manila service in OpenStack, there's direct integration between Manila and CephFS so that you can do NFS as a service to your cloud instances. And in terms of the whole scalability and manageability theme of Mitaka, Ceph Ansible, Ansible is just taking over the world in terms of automation, but using 2 commands to deploy Ceph is much easier than having to do a ceph.conf and ceph deploy, which might have taken you half an hour. Now you can do it in 2 seconds. Performance and time is very, very important. So things that are in progress is Manila and CephFS as file as a service. Blue Store. So this is really interesting. So POSIX has a number of advantages, aside from standardization, and we're familiar with it, but it also has a number of challenges, specifically around atomicity. Always struggle with that word. Around writes and the double write, and then also for those that are familiar in the internal workings of Ceph, we have a journal to accelerate writes. So what Blue Store is, some of you might know as formerly known as New Store, is writing directly to a block device with no file system. So we skip the VFS layer in the Linux kernel. So that accelerates performance by many orders of magnitude. So again, for some of you that have been following some of the stuff that's been happening at Tokyo and Austin summits, there's been a lot of mud slinging around, mine's faster and better, and some of it's true, some of it's not. But in terms of where the community's going, certainly performance is always something that people are wanting to increase and reduce latency. So Blue Store is really cool. Active multi-master object stores, so particularly around multiple data centers, or for those of you who run large organizations that are global, being able to read and write objects on every part of your Ceph deployment clusters in, say, Sydney, Brisbane, Melbourne, Singapore, New York, LA, right? So let's say you're an airline, for example, and I've got a mobile booking app, and I want to be able to have my customers have really fast mobile experience. So they might run, here's a product pitch. They might run Red Hat mobile application platform on our OpenShift PaaS on top of OpenStack, and they've got those deployed everywhere with Ceph, and they've got a global CDN load balancer that's doing geo IP routing, and I get the closest point of presence to where I am in the world. I might be in Spain, wanting to, I'm at Barcelona, wanting to come back to Sydney, and I'm checking my Qantas flights, and I get access to the European data center, and I can read and write my objects anywhere in the world. So I don't have to write back in Sydney, but I can read somewhere. We can do multiple writes. It's difficult, but really cool. A lot of object stores, while they give you the REST API of S3 or Swift, you've got a lot of legacy applications that need to address that same data, but so far there hasn't been an interface. And then you might have seen there's things like S3FS, which is awful, but in some respects solves a problem. So people wanting to have an object store as a file system. Now, inherently they are fundamentally different, but it's still a valid business problem. So Ceph is going to have an NFS gateway that's NFS v4 only for legacy application access. Now, it's not going to be a file system. It's not something that you'd use day to day, but it's something that is there for your transitory applications as you potentially rewrite them to be microservice, Web 2.0, jargon-compliant applications. There's been a lot more work and deployments and interest from customers around using Ceph as a pure play object store, and with or without OpenStack. So at the minute, we can do authentication and authorization with Keystone, but not everyone wants to deploy Keystone. So they want to use their existing directory service. Most customers have Active Directory. It's not an enterprise directory service by any means, but that's what most customers use. So Ceph will have native integration into things like Active Directory for user authentication and authorization. AWS 4 support, so for those of you who are looking at S3, that's coming. For Swift, Keystone v3, which is kind of important, some nice cool stuff there. Object expiration and tenant namespaces, so I can have multiple tenants in the same pools. And large, static large objects. So effectively that means something that Amazon has been very good at with S3 is serving static HTML content from their object store. So being able to do the same thing from Swift in OpenStack and Ceph. RBD mirroring. So at the minute, I'll admit, moving data between Ceph clusters at a block layer is a bit manual. You do a snapshot, you replicate it, and then you import it. So the community has been working on this to have direct RBD mirroring between clusters so that you can do disaster recovery and all of the things that you expect in an enterprise scale storage system. So this is an interesting thing, especially in very large Ceph clusters. Client I/O is going to be prioritized above scrubbing. So Ceph has a lot of background health things that run, so scrubbing to protect writes or to make sure that you don't get bit rot, things like that. So making sure that the actual applications get priority over the health of the cluster without sacrificing the health. And containerizing Ceph. So containers are the new cool kid on the block, even though Linux has been doing it for 10 years. But Docker made it portable, and it's a nice packaging format. So running Ceph as a container inside your platform as a service, inside OpenStack, and giving your developers complete control over how they deploy and develop their applications, not just in the application frameworks, but in their software-defined networking and their storage as well. So that as an operator, you can give them a whole pool of disk, and they can go and put Ceph on their deploy containers, and they can carve that up, and you can control that with things like a cloud management platform. So that pretty much covers it. So if, I think we've got 30 seconds.
Big round of applause for Andrew.